He kōna I purangi tēnei nā te reo irirangi o Aotearoa.
Kia ora, nau mai haere mai ki te ao hurihanga, ko Ellen Rikers tēnei. Hello and welcome to Our Changing World. Did you ever go rock pooling as a kid? I remember spending hours down at the rocks at low tide looking for starfish and crabs and shrimp. These rocky fringes are really important habitat for many marine creatures. But as we've built up urban spaces along our coastlines, we've lost some of this shoreline habitat. Our producer, Justine Murray, heads to downtown Tauranga, where 100 new rock structures were installed along the sea wall in May 2024. We join her to spend the morning with some marine science students to find out how these sea pods are helping the marine life of Te Awanui Harbour.
This recreational space on the northern waterfront reserve used to be a car park, but the council spent about $44 million as part of its redevelopment. And part of that was installing sea pods to add to the current wall of rocks that line the seashore.
It's kind of just a bunch of stones with gaps in the middle, and the tide can come in and go out and flow through them, but it doesn't really retain any water. There's a bit of shape to it, but they're all kind of the same rock and the same kind of surfaces.
But if you look closely, you'll see that a few rocks look slightly out of place.
They're almost like a flower shape with a round bit in the middle and then round ones around the outside.
Yeah.
But I guess dimension-wise, they're about 1 metre diameter, and they're kind of round at the top, and then they're about 1 metre deep, and then the pools that are kind of cast into them are probably maybe more like 400 mils deep.
And there are other names too, like
Seawall enhancement pods is our current best or favourite description of them, yes.
Seawall enhancement pods.
Yes.
or a living seawall or a living boulder. Now, all these names are not meant to confuse you, by the way. Just know that each panel, wall or pod are there to give a helping hand to marine life, which
kind of works a bit like a rock pool. So everyone's familiar with rock pools around the coast, and when you walk around the rock pools at low tide, there's always lots of interesting stuff living in them, right?
This is marine scientist Dr David Culliford. He's a marine studies lecturer at Toi Ohomai Institute of Technology here in Tauranga.
The idea of them is they produce like a 3D texture, so you've got more texture for things to go to kind of live in and grow on and explore or settle. And then you've got the retention of water like a rock pool, which is kind of going to keep stuff in there when the tide's out.
Yeah.
This morning, he and two of his students are monitoring the sea pods. It's low tide at the moment, and there's already been a bit of interest.
We're already into it.
Okay.
So, and I've already just had a cool chat with a member of the public who's interested. We always get lots of...
It's an overcast kind of day, and out on the water there are about 30 boats of different sizes bobbing up and down. There are families here with their kids, a few walkers and cyclists.
It's looking pretty nice down here at the moment. Lots of people wandering past and enjoying it.
So, Dave, all along this stretch of harbour is what 100 metres that we have the sea pods?
Yeah, so there's 100 in numbers of the individual pods, and probably, where are we? Just trying to give it some scale.
Yeah.
I guess from the wharf to here, we're probably looking at a couple of 100 metres.
100 metres?
Yeah.
And as we're looking down into the seawall, I notice that some sea pods are lying flat while others are on a 45-degree angle. And I'm wondering if this is on purpose.
I guess that could be useful information for building these things in the future, saying, if we don't want sediment to build up in them, we might put them at more of an angle, or if we want more water to stay in them, we need to put them at less of an angle. So the results will kind of influence, some of the thinking about how they position them in the future.
And when thinking about the future of this harbour and many harbours around the country, you have to look to the past, because this harbour, just like many around the world, sit on reclaimed land. With the rise of industry, shellfish and marine organisms were deeply impacted.
There's a tapas bar over there, and if you look next to that, there's some old piles which were part of the original harbour structure. So, and they're probably more like 100, 150 metres back from where we are right now. So yeah, quite a way back. So we're sitting on kind of a really modified area anyway. Yeah, I guess the point we were kind of talking about how not a lot of stuff can grow on these rocks. You don't get a great amount of biodiversity. So biodiversity is good because you get lots of different things living there, and then that kind of works its way back up the food chain where lots of other things can feed on that and kind of creates this healthier ecosystem for the harbour.
And that's the main function of these sea pods, to provide a new home for marine life. And because, as I mentioned, it's low tide, it's a good time to see what's going on inside.
What we're actually looking at and monitoring is the settlement and succession of marine life as time goes on. So initially what you get, if you put anything in the marine environment, after a certain amount of time, or almost within weeks, a brown sort of biofilm will start growing on it, which is often things like bacteria and diatoms, that sort of stuff.
Diatoms.
Which are just a photosynthesizing kind of very tiny organism. And then over time you'll get things come in which might feed on those, or things which are kind of settling on hard substrates.
We'll come back to my kōrero with David Culliford and his students soon. From Tauranga Harbour to Sydney Harbour, a city with one of the most picturesque harbours in the world. You can take the ferry across to Manly, visit the Sydney Opera House. It's an iconic place to visit. And while these man-made structures like harbours, bridges are all part of urbanisation, you can only imagine what this has caused for marine life below the surface. Aria Lee is a marine ecologist and invertebrate ecologist at the Sydney Institute of Marine Science. She's the project manager, Living Seawalls, and this is the Institute's flagship program, born out of a need to help marine life.
We have lost 50% of the natural habitat, natural shoreline habitat available for the marine organisms in our area. Now we're at the point of addressing, well, what can we do to return biodiversity to these urbanised areas? And Living Seawalls is one solution that is really working around harbours.
A living seawall was an innovative way for microorganisms to live and create new habitats.
Our very first living seawall installation, where we actually retrofit the habitat modules to the wall, was in North Sydney at the end of 2018. We've been conducting ecological monitoring and evaluation at that site since then, and we have found that we were able to increase the number of species living on the living seawall by up to 36% when compared to our comparison seawalls where we didn't modify at all. So we're reintroducing habitat, we're reintroducing habitat variety, and so we can increase biodiversity that way and also increase the number of organisms in general.
Sydney Harbour, also known as Port Jackson, is about 54 square kilometres and is one of the world's largest natural harbours. So more living seawall panels were installed.
We have over 20 living seawall sites in Sydney Harbour now.
That is good news for the health of the Sydney Harbour and these organisms that are also super important. This biodiversity and ecosystems help humans. They help us out by cleaning water, acting like filters by removing pollutants and sediments. The problem stems from urban development, and let's be honest, that is probably not going to slow down anytime soon. Here's Dr Aria Lee again.
When you look at an artificial structure such as a seawall or a wharf piling, they're generally vertical and smooth. So a lot of the seawalls are made out of concrete. And this smooth vertical surface doesn't provide any type of variation, no microhabitats for organisms to colonise. And also that smooth surface doesn't allow for things like seaweed and oysters to really hold on to the substrate, so they can get washed away really easily.
So flat and featureless doesn't work. A living seawall offers a new kind of home.
When you think of a rocky shore, you can notice a lot of variation in the surfaces. So there's a lot of crevices. So the concept that Living Seawalls has put forward is that we can design these habitat enhancement modules that contain features of the natural shoreline.
Living seawalls, or living boulders, are now in harbours around the world.
We have over 30 living seawall sites worldwide on 5 continents.
They're in Peru, the United States, and also places in Europe and Asia. And of course, in Tauranga, the living boulder, or known in Tauranga as sea pods. It's a collaboration partnership between the Sydney Institute of Marine Science, Toi Ohomai, the University of Waikato, Port of Tauranga, and Tauranga City Council.
Structures like rock revetments in Tauranga, it's covering up what was naturally there. That one of the natural habitats that disappear is that you cover up all the rock pools.
So putting back in the rock pools, these organisms are able to seek refuge to avoid from drying out or to shelter from predators. Living Seawalls is, as I mentioned before, a flagship program at Sydney Institute of Marine Science, with collaborations alongside marine ecologists from the University of New South Wales, Macquarie University with the Industrial Design, and Reef Design Lab in Melbourne. A living seawall is eco-engineering at its finest. So what is the design process?
The way that they're made is that they're just cast in concrete using silicon molds. We use an eco blend of concrete that uses some recycled materials to reduce the amount of cement that's being used. But we are also working with materials scientists who work with different concrete materials, low carbon concrete, carbon neutral concrete, and things like that to see if they're useful.
And when the time came to design and make the 100 living boulders or sea pods, remember these things weigh up to 1.2 tonne each to be installed in the Tauranga harbour, Aria and her team were part of the conversation.
We didn't want to manufacture them in Australia and send a heap of heavy concrete over to New Zealand. So for this project, we collaborated with a manufacturer in New Zealand called Hines. We shipped over some of the moulds to mould those giant boulders, and they were manufactured in New Zealand.
Back on the Tauranga waterfront, I'm with marine scientist David Culliford and 2 of his students, Taylor and Tiff. Now they're monitoring the sea pods. This waterfront stretches around 200 metres, right in the heart of downtown Tauranga. So when the boulders were first installed back in May 2024, at first the monitoring process was kind of like watching paint dry.
Early on was quite slow, kind of watching what was growing. It was just like this brown, scungy biofilm.
But things picked up.
But then we started finding stuff that was coming in, feeding on it, and some quite exciting things. We found nudibranchs, which are like a colourful sea slug, and we found different types of snails laying eggs, and little calcareous fan tube worms.
Tauranga is the first city in Aotearoa to have sea pods installed at the harbour. But David's heard that other regions have adopted the same type of eco-engineering.
I really enjoy the kind of rock pooling element of this. It's like being a kid again for me, going down there and looking in the rock pools every day. So it's kind of a really interesting, exciting part of my job. But there is another project that I'm aware of going on down in Wellington related to the cycleway, which is some subtidal versions of these, which are kind of always covered underwater, but again, same principle. They're kind of interesting shapes that attract marine life to be able to populate and live in. So yeah.
What's the difference, Dave, between the on a wall
been flat versus this just purely, is it a tidal thing or just...
Yeah, no, it's very similar. I mean, if you've got a flat wall, imagine that. So you've got this kind of surface here, which I'm just pointing to a flat piece of concrete, and it's not very exciting for marine life to populate. Certain things they would find this perfect for them. So things like mussels would love to grow on here, maybe in barnacles and things like that. But you wouldn't get that biodiversity or all these different things that might live on there. So different marine life has different kind of requirements for where it wants to live and how it wants to grow, and having a really complex kind of structures like this for things to grow in means you attract a lot more stuff.
I can see a hint of green algae. Does that happen in here?
Generally, if you kind of go and take a look, you'll see this brown biofilm covering everything, and that's kind of got thicker. You'll see a bit of sediment in the bottom. You'll see kind of the green algae growing around the top, and that's just kind of the background stuff that we've got that's living there. And maybe you'll start seeing some sort of things like branching algae, and we've even found little sponges. And related to some other work that's going on with Waikato, you've read about the sneezing sponge? Have you seen that?
No, I haven't.
Oh, you should go and have a look up for the sneezing sponge.
Sneezing sponge. I did look it up. In fact, it made the news in January 2024.
Sea sponge, which looks like a cauliflower and can sneeze.
So if they get covered in sediments, they need to get rid of that if they can. And so this particular group of species will sneeze and it'll just fluff off again.
Researchers came.
So a sneezing sponge is as fascinating as its name suggests. It doesn't exist anywhere else in the world except in the Tauranga harbour. And David remembers that exciting discovery.
I used to work with Chris Barashil at the Waikato Uni, and they discovered a sponge under where the blue cargo shed is. But what we found was Taylor was down there with Chris one day, and they found what they thought might be the first kind of colonisation by some of the sneezing sponge from further up in the harbour. So that's cool.
Student Taylor Rabbitt is out monitoring the sea pods, and she's with her classmate Tiff. I can watch them. I can see them gently walk over the rocks, kneeling down, peering inside the pods and making notes on a clipboard.
Taylor's been coming down here while the pods are exposed.
So it's good that it's low tide. Taylor's hometown is Florida, but she's lived in the country for 7 years. She has a background in scuba diving. That and her studies is a good fit.
So I am doing pod surveys today, looking at different abundances of organisms living inside the pods, and then algal cover and algal growth inside the pods as well. Wow. Basically, I have a metal square that's called a point intercept quadrat, and I place that inside each pod, and I count underneath each intercept point that has algal growth underneath. And that gives us a way to calculate percent algal cover that's more specific than just trying to calculate it by the iometer or the eyeball.
Right.
So I've collected the data. I write everything that I see, all the measurements that I take, and then I go and I put it into an Excel spreadsheet and then analyze that later on to see the trends and the changes that happen over time.
So the sea pods have been here for 1 year as of May, and Dave talked about you're involved in the summertime. You came here weekly to clean them out and that type of work. Can you talk us through that a bit?
Yeah, absolutely. So over the summer, I've done this same exact method where I use that point intercept quadrat, and I did this weekly to watch the changes through the summer, because the idea was the warmer weather might increase things like algal growth and bring more creatures in. So we wanted to watch that in a specific time period, or like a shorter time period. So we did weekly surveys, and
any trend or the trend that you noticed, or too early to
yeah, so definitely the pods appear to be increasing biodiversity in the coastal regions compared to the surrounding rocks. Like, we definitely found more life inside the pods than the surrounding rocks, and we did surveys to compare both the pods to the surrounding rocks as well over the summertime.
So the weather's going to be changing soon to a more colder climate. Do you foresee any changes there versus our summer?
So for my second year project, I have actually started looking at seasonal variations within the pods. So I've cleared out a few of the pods to look at the differences in settlement depending on the seasons.
Yes.
So that is what the project we're working on now. And we are expecting to see changes because there have been studies done elsewhere around the world that has occurred. And yeah, so looking forward to it, yeah.
These sea pods can weigh up to 1.2 tonne each. That's well over 1,000 kilos. So they had to be craned into their position. It took a bit of work, time and money, with a price tag to install the sea pods at just under $4 million. The port of Tauranga is the largest port in the country, and they helped out financially. It's all part and parcel of their strategy to support sustainable practices like the living seawall. I caught up with Rachel Lockley.
The living seawall is quite a big undertaking for the council, and so they were really looking for a partner that could fund this big investment. And so we were happy to come to the party. I guess what really resonated with us is that it was an enhancement of the marine environment. It was something that was happening on the coast, and being a port, we have a strong affinity to Tauranga Moana and the harbour and its creatures, big and small.
Oh, really?
Yes. So just watch out. Do you want me to help carry anything?
No, I'm okay.
Just watch out for the cracks.
Back to the sea pods. This time I walk over the rocks. It takes a little bit of manoeuvring. I join Tiff, Taylor and David to get a closer look.
More stuff, right, Taylor? So the stuff we're looking at is really small here, and if you kind of put your... Oh yeah, look at this. Oh, an exciting find. So you see this little thing here? You can see it moving?
Yeah.
Like a Spanish dancer. It's there you go.
Flatworm.
So that's a flatworm, yep. What else have we got? We've seen some shrimps this morning. Heaps of shrimps.
Heaps of shrimps.
They seem to be like little shrimp hotels, so we find loads of them in here.
I love that shrimp hotel.
When someone walks by and you end up with a KFC chicken bone in here or something, they pick it clean really quickly. Yeah, they seem to really like it in there.
What about the quality of the water, Dave? How are we faring there with Tauranga Harbour?
Yeah, one of the concerns at the start was kind of the sediment build-up.
Yeah.
So we've been monitoring that closely, and we kind of measure it each time we go. But we did sort of notice that it started to build up at the beginning, and then sort of certain conditions where you're getting a bit of wave action seems to remove the sediment again, and then it kind of starts building up again. So they don't seem to be completely filling up and inundating with sediment. So I think over time we'll just see that kind of cyclical, a bit of sediment build up and then sediment removal kind of going on with wave action and currents.
David and I end our chat for Our Changing World with a stroll down the waterfront.
This is a really good example of, against the backdrop of development, how we can look after our harbour.
And David spots something in the water.
Direct. What's that? That's an eel.
Oh, there's an eel.
Oh, wow. That's something you don't see in the sea very often.
That was very cool.
Yes.
It's the first time I've seen an eel down here.
Yeah. I've seen them further up in the harbour a few times, but not actually just swimming by like that. Wondered whatever it was at first. Yeah.
What does that tell you? Anything that
it tells me there's an eel in here doing something. But I think that so eels.
Low tide.
Eels actually breed in the marine environment, but live most of their lives in freshwater. So maybe it's on its way to potentially Tonga or somewhere like that, where they're thought to breed. Yeah.
Thanks, Justine. Justine spoke to Dr David Culliford and Taylor Rabbitt from Toi Ohomai Institute of Technology. She also spoke to Rochelle Lockley from the Port of Tauranga and Dr Aria Lee, a marine ecologist at Living Seawalls. You can check out photos of the sea pods on our website, rnz.co.nz/OCW. This episode was produced by Justine Murray with production help from me, Ellen Rikers. Sound engineering was by William Saunders. Claire Concannon is the presenter and producer of Our Changing World. Tēnā koe I whakarongo mai. Thanks so much for listening. Have a great week. Kia pai te wiki.